Welcome to yet another episode where we shall be looking at the proposed memorandum for mathematics paper 1, June exam 2025. This one is from Limpopo for mathematics. Okay, so the paper is 3 hours for 150 marks. We have 8 questions that we need to work on. All right, and then we need to answer all the questions. Okay, so when we look at question number 1, which is the algebra solving for x, okay. So 1.1.1, if we have x squared minus 121 is equal to 0, so this is a difference of 2 squares. Let's factor this out. So we're going to have x minus 11 and x plus 11 must give us a 0. Okay, since it's already a standard equation. Then the first bracket will give us a positive 11. The second bracket will give us a negative 11. So those are the two answers that we need. And then 1.1.2, x squared plus 3 is equal to 5x to 2 decimal places. Okay. So we have x squared plus 3 is equal to 5x. Okay, so first things first, we need to create a standard equation. That's going to be x squared minus 5x plus 3 must give us a 0. So from this, we know that our a is a 1. Our b is a negative 5, and then our c is a 3. So whenever they ask us to give the answer 2 decimal places, our minds should run away to, or rather they should run towards the quadratic formula. So x is negative b plus minus square root of b squared minus 4ac. Everything is over 2a. So if we substitute negative, which is a 5, plus minus square root of, that's going to be negative 5 squared, minus 4, the a is 1, the c is a 3. Or this is divided by 2 by 1. Okay, so when we punch this into the calculator, let's see what we have. So it's x. Okay, so I'm getting 0.69. That will be 0.70 because the 697, so 0.70. And then the other x is a 4.30. Okay, so that is what I'm getting for 1.1.2. Okay, then 1.1.3, we have the inequality, quadratic inequality. So x minus 1, x minus 5, x minus 1, x minus 5 is less or equal to 12. So first things first, we need to open up the bracket, okay? And then opening the bracket, we're gonna have x squared minus 5x minus x plus 5 minus 12 is less or equal to 0. Simplify that, it's going to be minus 6x. This and that is going to give us a negative 7, it's less or equal to 0. Let's factor this out. Okay, x and x. With a 7, we must have a plus 1 and a minus 7. Meaning that our critical values are going to be negative 1 and a 7. Okay, so how do we represent this? So there are 3 ways to represent the solutions of this. So meaning that the negative 1 should be less or equal to x, less or equal to 7. Okay, the other alternative is whereby you have to draw the parabola. The a is positive, meaning that we can have something like that. This is your negative 1. This is your 7. This is the area of interest. Okay, so that is how we would have represented those solutions of ours. Okay. And then 1.1.4. This is an exponential equation. So with exponential equations that have plus or minus, we need to factorize. So let's take the 2x out. Okay, we're going to be left with a 1 here. plus, we're going to be left with a 2 squared, which is a 4. Should give us a 40. Then we know that 1 plus 4 is a 5. So 2 to the x is going to be 40 over 5. 2 to the x is the same as 8. Let's change the 8 to a base of 2. 2 to the x is the same as 2 cubed. So the bases are the same, meaning that our x must be a 3. All right, that's wonderful. Okay, then question 1.1.5, we have the square root. Okay, 1.1.5, we're saying the square root of 10 minus x squared. Okay, we are subtracting x, we are adding 2, and then we are equating to 0. So first things first, we need to isolate the third or the root form. So this should be left on one side, let everything move to the other side. So you're going to have square root of 10 minus x squared is equal to x minus 2 when this move that side. Then step number 2, we need to square both sides, okay, so that we get rid of the root sign. So we're going to have 10 minus x squared is equal to, that's going to be x squared minus 4x plus 4. I would move everything to the right. This and that will give me 2x squared minus 4x. When the 10 goes that side, I'll have a negative 6 is equal to 0. Then I can divide through by 2 so that I have x squared minus 2x minus 3 is equal to 0. Quadratic formula of vectors, that's x and x. This can be a 1 and a 3. I'll put a negative and I'll put a plus. Okay, so either my x is a negative 1 or my x is going to be a positive 3. Now, for questions that have root signs, okay, the last step is for us to test the answers that we have, okay? Remember, initially, our equation was the square root of 10 minus x squared minus x plus 2 should give us a 0. So we just need to substitute each one of them one at a time, okay? So if I use negative 1, that's going to be 10 minus 1, which is 9. And then the square root of 9 will give me a 3. And then when I subtract a negative 1, and then I plus a 2, this becomes a plus 1, meaning that I have my answer as a 6. And yet on the other side, I have a 0. So this one is not clicking. So I'll say it's not a solution. Let's try with 3. We know that 3 squared is a 9, so 10 minus 9 is a 1. Square root of 1 is going to be a 1. We are subtracting 3. That's going to give us a negative 2. When you plus the 2, you get a 0. So this one is giving us the answer on the right hand. So 3 will be the only solution that we have. All right. 1.2, solve simultaneously. Okay. If this is our equation 1, this is equation 2. From equation 1, we can see, we can move this x that side. So that y is going to be x plus 2. Let me call this equation 3. And then we need to substitute equation 3 into equation number 2. Okay, so I'll put it this side. This is 1.2. 1.2. So we have x squared 2xy. Okay, x squared plus 2xy minus 4 is 0. But we said our y is going to be x plus 2. Is that true? Good. Okay, so we just substitute this where there is y, we punch that there. So it's going to be x squared plus 2x into x plus 2 minus 4 is equal to 0. X squared plus, this is going to be 2x squared plus 4x minus this 4 is equal to 0. That is 3x squared if we'll collect the like terms, plus the 4x minus 4 gives us a wonderful 0. All right, then I can use my quadratic formula, or I can do the factors, okay? So that's 3x and this is x. For me to get a 4, I can use 1 and a 4, or basically 2 and 2. But looking at my sum here, if I put a 1 here and I put a 4 here, let's see. If I make this a minus, this a plus, will it give me what I want? Nope. Nope. Because this is gonna be minus 3x. This is gonna be a plus 4x, which gives us just x. So my orientation could be wrong. So let me switch the 4 and the 1. 1 and the 4. Still, this is a 12. This is a 1, which means it's not making sense as well. So 1 and 4 cannot work for me. Let me use 2. Okay, if I use 2 and 2, that is 6 and that is 2. Perfect. So that's a plus and this is a minus. Okay, so meaning that my x is going to be a 2 over 3, or x is going to be a 2, negative. Then I need to substitute this x into the equation of x plus 2 for the y. Okay, so if I do that, it's going to be 2 over 3 plus 2, which makes it 8 over 3. Or if we use a negative 2, then y is going to be a 0. So these are the solutions that the question basically wanted for the 5 marks. All right. 1.3, they're telling us that if f of x is given as this, g of x is given as this, where a can never be 0, b can never be 0. If x minus a is a factor of f of x, and if x minus b is a factor of g of x, can we prove that d minus 1 is equivalent to that? Wait, okay. The only thing that I believe will guide us is this. What is a factor? A factor is something that is divisible, okay? That element that is divisible into the function. So from these factors, we can obtain the roots, meaning that x minus a equated to 0, meaning that x is a. If we substitute this a in the place of x into this function, the result must be a 0. Same thing with x minus b, equated to 0, meaning that x will be a b for the g of x. Okay, so let's try that and see. So we are replacing x with a, meaning that we're going to have a into a plus a minus b. This must give us a 0. Open up that, we're going to have 2a squared, because this is 2a and then a, 2a squared, minus b 0, which means our b is a 2a squared. What is the question not having? The question is not having a d. In other words, the answer is not having a b. That's why I would rather make this, so I'll call that equation 1. Let's focus on the g. We do the same thing, so it's going to be 2b squared plus the b, which is already there, minus b times the x, which is a b now. Do we have any like terms? Nope. That is equal to 0. And then I just need to get where there is b. I have to replace it with 2a squared. This is equation 2. And we're saying substitute equation 1 into equation number 2. So we shall have a 2 into, this is 2a squared, but squared. Hey, where are we going? Where are we going? Plus, we have 2a squared minus a d into 2a squared is equal to 0. Okay, let's see. What is this going to give us? This is going to be 4a to the 4, then multiplied by that, which is 8a to the 4. But why must I open that up? Because I'm seeing something that is easier to approach or to use. like there's a 2a squared everywhere. Divide by 2a squared, by 2a squared, by 2a squared, by 2a squared. So this kills one of them, meaning that I have 4a squared plus a 1 minus a d is equal to 0. Then move the d to that side. So that d is just 4a squared plus 1. Isn't that what the question wanted? Oh, they want the 1 to be that side. Okay, meaning that we need to move this one this side. So that we get d minus 1 is 4a squared. All right, so that's what the question simply wanted for the other 5 marks. All right, question number 2, sequences and series. They're telling us that the 19th term of an arithmetic is 11, while the 31st is 5. Determine the first 3 terms, then they want the general term. Okay, so I'll put it this side. This is 2.1. Okay, so T19, we have T31. Okay, T19 is what? 11. The other one is 5. Is that true? 11, 5. Perfect. So let's use the general term of an arithmetic, which is a plus n minus 1 into d. So when we're talking about T19, okay, I'll have 11 is equivalent to 19 minus 1, which is 18. Okay. Then we can make a the subject and say that a is going to be 11 minus 18d. Call that equation 1. Let's come to the 31st. So T31 is 5, meaning that 5 is equal to a plus a 30d. You can make a the subject again, meaning that a is a 5 minus a 30d. This is equation number 2. Then I'll equate equation 1 to equation number 2. So 11 minus 18d must give us 5 minus a 30d. Let me move this 5 to that side, move the 18 to that side. So 11 minus 5 gives us negative 30d plus 18d. So 11 minus 5 gives us a good 6. And then negative 30, and that is a 12, negative 12d. Let's divide through by negative 12, meaning that our d is a negative 0.5, or somebody can write it as a negative a half. But then we need to get the value of a as well. So our a is going to be 11 minus 18 times negative a half. So meaning that our a must be a 20. Okay, so that is what I'm getting. But then the question wanted the first 3 terms. Okay, so T1 is a 20. Then 20 minus a half. Okay, or 20 plus negative 0.5. What do we get? We get 19.5. Or someone would write it as a 39 over 2. And then you subtract 0.5 again, you get 19. And then the story continues. All right, so that is 2.1.1. Then they want us to get the general term for 2.1.2. 2.1.2, they want the general term. So we know that Tn is a plus n minus 1 into d. We said our a was a 20, n minus 1 into, we said this was a half, but negative. Let's open it up. So it's going to be negative a half of n plus a half, and then plus 20. So negative a half of n. When you do your magic, we shall be left with a 41 over 2. We could write it like that. Or you could leave it in decimals. No stress. Then 2.1.3. And they want us to get the sum of the 81 terms, the first 81. Okay, so sum of 81 terms. Let's start by writing the formula. So n over 2 into 2a into n minus 1 multiplied by d. So S81 is going to be 81 over 2. 2 multiplied by 20 plus 81 minus 1 multiplied by negative a half. All right, so when we punch this into our calculator, saying 81 over 2, okay, that is it. That is 80 divided by 2, it's going to be negative 40. I'm getting an answer of a 0. That's what I'm getting. Okay. So the sum of the first 81 terms will give us a 0, since we have positive numbers as well as negative numbers. All right, then 2.2, they're telling us we are given the quadratic. We have 2, 5, 10, 17, and 26. What's going on here? So this is a plus 3, a plus 5, plus 7, plus 9, meaning that we must plus 11. So when you plus 11, you're going to have a 37. And then you plus 13, you're going to have a wonderful 50 there. Okay, so the next two terms are basically 37 and then 50. And then can we show that Tn is given is the general term of the quadratic? So we need the second difference, which is 2, 2. So if our 2a is equal to 2, okay, meaning that a is going to be a 1, then 3a plus b should be equated to 3. And then if a is 1, meaning that b is going to be a 0, because this will be a 3, subtract by 3, get a 0. And then a plus b plus c must give us a 2. This is a 1. This is a 0. C becomes a 1. Okay, so Tn becomes n squared plus 1. Okay, so that's how you obtain that. We're going to give you marks for A, for B, as well as for C, and then the general term. 2.2.3, determine the term of the pattern that has a value of 290. They want us to get the n, the position. So if we have our Tn, okay, let me put it aside. So if our Tn is n squared plus 1, we need n if our Tn is 290. Is that correct? Yes. Okay, so it's a 290 is equal to n squared plus 1. Let's move the one that side. We have 289 is equal to n squared. Let's find the square root. So n must be somewhere around 17, because that's the square root of that. Okay, so the 17th term is what the question wanted. Then between which two consecutive terms of the quadratic will the first difference be a 25? Okay, if we say 13, then the pattern continues. We're gonna get a 25 somewhere there. Now, one thing I need you to identify is the pattern on how this thing works. That the first term of the first difference will be between T1 and T2. The second term is T2 and T3. The third term is T3 and T4 and so on. So let's get the position of this 25, okay? By that, we know that the first difference is an arithmetic. Let's get the nth term. Tn is going to be 2n plus 1. Okay. If that is 2n plus 1, I'm going to equate this to a 25. I'll move this one that side. I'll have 2n is a 24, then divide both sides by 2, meaning that n is 12. This is the position of this, meaning that this 25 is between T12 and T13, between which two consecutive terms. So T12 and T13. Okay, so that is where I am getting according to my approach, okay? Then question number 3. Wow. Square A has 2 centimeters each. The length of square A is a half the length of square B. And the length of B is the length of C is double the length of B, meaning that B is a half of C, and so on. Then the question is asking us to determine the length of each diagonal of the square. Okay, so if this is a 2, this is a 2. This is a diagonal. Okay. If that is true, what do they want? They want the square A, the length of A only. So which means that it's going to be, if a square, there's a 90, so Pythagoras, meaning that 2 squared plus another 2 squared must give us the diagonal, but under the square root. If I call this a P and a Q, so we know that PQ is going to be 2 squared plus 2 squared, and then you find the square root. So this is going to be 4 and 4, which is 8. So the square root of 8 is going to give us 2 root 2. Okay, so this is what we are getting, okay? And then they want us to get the area of C. So if this is 2 and 2, meaning that this must be 4 and 4. And then this one must be, because they said double. So that's going to be 8 and 8. I don't know, does it make sense? Yes, so meaning that the area is going to be 8 by 8, which becomes 64 centimeters squared. This must be centimeters. Okay, then 3.3, can we show that the sum of areas of the first 10 squares is given as that? So now the question is changing goalposts. They started with diagonal, they asked the area, now they're asking about the sum of the areas. Okay, so if the first area is a 2 by 2, which is a 4, the second area is 4 by 4, which is a 16. The next area is 8 by 8, which is a 64. This is a geometric, okay, with a common ratio of just 4. Okay, so they want us to get the sum of the first 10 terms. Okay, so I'll write it aside and say this is 3.3. So our A is a 4, the common ratio is a 4. So sum will be A into Rn minus 1 over R minus 1. So S10 is going to be 4, open brackets, 4 to the exponent of 10 minus 1 over 4 minus 1. Okay, so let's punch this into our machine and see. So 4 to the exponent of 10. Okay, we are subtracting a 1. Close the brackets over 3. Okay, I'm getting 1398, 100. I think this is what the question gave us. 1398, 100. Okay, so that is how we obtain that. Then we move on to 3.4. Can you show that the length of each diagonal in the N is given as that? So this question, meaning that we need now to find the general term of the diagonals. Must find the general term of the diagonals. So if this is 2 root 2, this is 4 by 4 under square root. So it's 4 squared plus another 4 squared, which gives us 4 root 2. Okay, so this is going to be a 4 root 2. Let's try with 8. So 8 squared and then another 8 squared. It gives us 8 root 2. Okay, so I'll put it aside and say the first one was a 2 root 2. Then we have a 4 root 2. And then we have 8 root 2. This is T1, T2, T3. What's the common ratio? The common ratio is just a 2. They want the general term. This is a geometric, so it's AR to the exponent of n minus 1. So our A is a 2 square root of 2. We are multiplying it by the R, which is a 2 to the exponent of n minus 1. Okay. Then we know if I am to split this up, it will be 2 square root of 2 multiplied by 2 to the exponent of n and then 2 to the exponent of negative 1. But we know that anything to the negative as an exponent can be written as just a fraction, okay? So it's 2 root 2 times 2 to the n times a half. So this 2 cancels that, meaning that we just left with square root of 2 multiplied by 2 to the n. Isn't that what the question gave us? Yes, there we go. All right. We're winning. 3.5. Determine the square that has a diagonal of this. So we have the general term, okay? So meaning that Tn is gonna be square root of 2 times 2 to the exponent of n. Now, if the Tn is this, so I'll just equate this to 2, 5, 6, and the square root of 2. So step number 1, the root signs are going to cancel each other. Okay, this cancels that. And then 2 to the exponent of n. If I'm to write 2, 5, 6 in exponential form, it's basically 2 to the exponent of 8, okay? Meaning that the 8th term or the 8th square is what the question is looking for. Okay, so that is question number 3. Question number 4, functions. The sketch below shows the graph of the g of x, which is a parabola. Points A and C are x-intercepts. T is the turning point of G. T is the turning point of G, okay? Then graph F cuts G at C and B, okay, respectively. Then E is symmetrical. Okay, this is symmetrical to D. Oh, what do they mean by that? So if this is the axis of symmetry, the distance from there up to here is the same distance from there up to there. That's what the question means, okay? That if we have our axis of symmetry here, or if we have our turning points, the distance from there up to there must be the same distance from there up to there, meaning that the y value is going to be the same. It's going to be a -6. We don't know the x. We shall find it. Okay, let's see. They want us to determine the coordinates of the turning point. 4.1.1. So turning point, we can use x is -b over 2a. Okay, to get the x coordinate. If not, you can find the derivative equate to 0 and you solve that equation, okay? So meaning that we're gonna have negative with a -3 over 2 times 1. So we have 3 over 2 as our axis of symmetry. But the question wants the coordinates. So meaning that we need to substitute this back into G. So G 3 over 2 is gonna be 3 over 2 squared minus 3 times 3 over 2 minus 10. Okay, so let's see what we have. We said 3 over 2 squared minus 3 over 2, subtracting a 10. I'm getting -49 over 4. So T is going to be a 3 over 2, -49 over 4. All right, then 4.1.2, they want us to get the range of G. So when you talk about range, you're basically discussing the Y values or the output values. Now, since this graph is a smile, and we have the lowest Y as a -49 over 4. So anything above -49 over 4 will be valid for this graph. So that is how we would represent that. And then determine the coordinates of C. So C is the x-intercept. And we know that at the x-intercept, Y must be what? Y must be a 0. Why is the question 2 marks? I don't know. I'll put it aside. 4.1.3. So x squared minus 3x minus 10 is equal to 0. Let's find the factors. This is x. It should be a 5 and a 2. I'll say minus and plus. Why is it a 5 and a 5? We said 5 and a 2. Okay, meaning that x is a 5 or x is -2. Therefore, C is going to be a 5 and 0. So we are saying this is a -2. Okay, so that's what the question wanted. Then 4.1.4 determine the equation of BC. Now, for us to get the equation of BC, which is the straight line, we already have this as a 5. We can get this point here, which is the y-intercept. This -10 here is automatically our y-intercept because x will be 0 at this point. So this is a -10. So all we need is just to find the gradient. I don't know, why did they give it 4 marks? Okay, so 4.1.4, let's get the gradient of BC, which is change in y over change in x. So that's going to be a 10 over 5. So 10 over 5 gives us a 2. So our gradient is a 2. And then our equation is going to be 2x. The y-intercept is a -10. Okay, that's why I'm asking, why is it 4 marks? It looks a lot. Okay, then 4.1.5, we must get the coordinates of E if E is symmetrical with D. If E is symmetrical with D. Okay, so we've got our x coordinate to be 3 over 2. Or somebody can call it 1, 5. So if this is a -1, so it simply means we have 1 unit that we moved, and then we have a 1, 5, meaning that the total distance here is a 2, 5. So even from this axis of symmetry up to point E, we must move 2, 5 units. So what is 1, 5 plus a 2, 5? That gives us a 4. Okay, meaning that E is going to be 4 and -6. Now someone asked, but then how do we get that? Okay, so for people that want to do the long calculations, we can equate the y to a -6 and get the x values, okay? So it would be more or less the same as x squared minus 3x minus 10 is equal to -6. Move this one that side, you have x squared minus 3x, -4 is equal to 0. Factor this out. We have x and x, a 4 and a 1, minus and then a plus, meaning that x is -1, or basically x is a 4. Then we said it's a 4 and -6. All right. Then next, for what values of x will this graph be positive? Okay, for what values of x will the graph be positive? Now we skip before we go to the positive part. They're asking us for which values of x will f of x be greater than the g of x? Okay, 4.1.6. Where do we find f to be above the g? So f is here and it's above here, between 0 and what? Between 0 and 5, meaning that our 0 must be less x and less 5. So between this interval, that's when we find the graph of f to be slightly above the one of g. All right, then 4.1.7, for what values of x will this graph be positive? Okay, so it's as good as solving the quadratic inequality, whereby we get this x squared minus 3x minus 10, and then you greater than 0, okay? But we already have our coordinates of -2 and then the 5. So it will be positive within this area or that section and positive above in that section. So meaning that our x, okay, needs to be less than -2 or x needs to be greater than 5. All right, so that is question number 4.1. Then 4.2. If we are given f of x as this, wow, this hyperbola is too basic. Okay. They want us to write down the equations of the asymptotes, meaning that x is going to be a -1, y is going to be a 0, because we don't have anything after this, okay? Then they want us to sketch showing the intercept with the axis and the asymptotes for 3 marks. Okay. So let me write it this side. We have f of x is 2 over x plus 1. Yellow. Okay, so the only thing we need to look for is the x-intercept. But will it even make sense? It will not make sense. Let's look for the y-intercept. So for y-intercept, x will be a 0, meaning that it's a 2 over 0 plus 1, which is a 2. So for y-intercept, x is a 0. So it's going to be 0 with 2. We don't have x-intercept in this format. Okay, so if that is our y, please forgive my line. It's not that straight, but it's fine. Okay, so if we have, we say the asymptote x must be -1 somewhere here. Okay, and then we say y is a 0. This is an asymptote on its own. So the graph is not going to cut this line. But our a is positive, meaning that we need quadrant 1 and then quadrant number 3. So 0 and 2, this could be our 2, meaning that the graph must pass somewhere there towards the asymptotes. Okay, and then the other arm must definitely be within this quadrant. So just draw there. You don't need any coordinates. It's just a sketch, remember? So we need the 2, we need the -1, and then the asymptotes. Done for 3 marks. All right, then 4.3. So if this f is translated to get g in a way that now we have a -2 and then we have a +2 here, discuss the translation. Okay, so one thing that we need to see or to understand is what exactly went on or what happened. Number one, for us to move from a +1 to a -2, especially with the x, it simply means that the new asymptote, instead of it being -1, remember initially it was -1, now it's going to be a +2. How many units are there? These are basically 3 units to the right, okay? So the graph was moved 3 units to the right. Then there was a 0 here, but now it's a 2. So it was also moved 2 units upwards. Okay, so we just need to indicate that f was moved. Okay, so 3 units to the right, and then 2 units upwards, or 2 units up. So that is the translation that took place. Then question number 5. The sketch below represents the f of x, which is a bx plus q, so this exponential, which intersects the y-axis at 0, 1 and passes through 2 and 9. Okay, beautifully drawn. Can we show that the equation of f is that? I like such questions that give you the answer, because we know we can never go wrong with this. All right, so we're saying y is b to the x plus q. Okay, let's start with this point. So if x is a 0, y is a 1. So 1 is equal to b to the exponent of 0 plus q. So anything the exponent of 0 will always be a 1. Okay, then that 1 will cancel that side, and then q becomes a 0. Meaning that our general equation now is going to be just a b to the x. Let's use this point also. So whenever we have 2 unknowns, you must make use of 2 points, okay? So where there's y, I'll replace with a 9. Where there's x, I'll replace with a 2. Let's express 9 with an exponent of 2. So it's going to be 3 squared is equal to b squared, meaning that our b is a 3. So meaning that our f of x is just a 3. to the x for the 3 marks. All right, then if f of x is that, they want us to get the inverse. So the inverse must always be the log. Okay, let me write it here and say that y is just the log x base 3. Okay, so that is what we have to do. Then they want us to sketch the inverse. We must show all the intercepts. So I'm going to use this graph of theirs. That's why I'm going to sketch my inverse. I know probably you were meant to sketch it somewhere else, but I'll do it here. So the only thing I need to do is switch the points. This was a 0, 1, okay? 0, 1 must translate to a 1, 0. And then we have 2, 9 must translate to 9 and 2. So where is 1, 0? This is a 1, 0 here. Then where is 9, 2? If this is a 9, 2 will be slightly above somewhere there. So we already know the format. So this graph is turning towards the x. This other one must tend towards the y. Okay, so we're gonna have something like that. Freehand, please, now, with your arrows. And then you call this the f negative 1 of x. That's the inverse. Okay, so that is what the question kind of wanted. Did they tell us to indicate any coordinates? They didn't. But if ever they need them, then we can just indicate whatever they were using initially. Okay, then 5.4. They're telling us that g of x is 2x minus 1. They want us to get the value of p. What are they doing here now? They're taking us back to sigma notation. Sure. All right, so let's see number patterns again. I thought we were done with the question. So if we're dealing with f of x and then we have g of x, we already have the equations, remember? So let's get the terms and try to establish what sort of patterns they are. And let's try to get their sums. Okay. So in the first one, if x is negative 2, because remember it was 3 to the x. So if x is negative 2, our first term is going to be 1 over 9. And then if x is negative 1, we're going to have a 1 over 3. And then x is a 0, we're going to have a 1. What does this mean? It simply means that 1 over 3 divided by 1 over 9 gives us a 3. So our common ratio is just a 3 for the first part. Let's look at the second one. With the second one, this is linear. Okay, so it's more like arithmetic. So if x is a 1, y, the first term is a 1. If x is a 2, it's going to be a 3, and so on. So meaning that our common difference is a 2, and then our a is a 1. All right, so having established those facts, we need to also know how many terms are there in both this one and that one. So for us to get the number of terms here, remember it's the last element minus the first one, and then you plus 1. So this is 7 plus 1, which means we have 8 terms here. Okay. Then for the next one, this one, the last minus that plus 1. So our n here is going to be 10 terms. All right, let's get the general equation, meaning that we have our a into r to the exponent of n minus 1 over r minus 1. We are subtracting the n over 2 into 2a plus n minus 1 into d. I would have found the 10th term, but no, it's fine. Let's just use this one. So we have 1 over 9 into 3 to the exponent of 8 minus 1 over 3 minus 1. We are subtracting 10 over 2 into 2 times 1 plus, we know that 10 minus 1 is a 9 multiplied by 2. All right, so the only thing I have to do is just play the diplomatic role and just substitute that for us into the machine. So when I punch that into the calculator, okay, we are subtracting, okay, into 2 plus that. I'm getting 2380. 2380. Let's just confirm that we did the right thing. Okay. All right, so we said we're getting 2380, but please just confirm this answer and see if I've done it correctly. Okay, then question number 6. Calculate the derivative of this from first principles. Okay. Let's get this side. This is 6.1. So our f of x is 3x squared minus 2x. Correct. So with the first derivative or with first principles, we need f of x, but we also need f of x plus h, meaning that it will be 3 into x plus h squared minus 2 into x plus h. So where there is x, we have to increase it with just a small h. Then the formula tells us that the limit as h tends to 0, f of x plus h minus f of x all over h. So we do the substitution. Limit as h tends to 0. We're going to have 3 into x plus h squared minus 2 into x plus h. But we are subtracting our f of x, which is 3x squared minus 2x. All this is over the h. Then limit as h tends to 0. Okay, limit as h tends to 0. Now we need to open up the bracket. And then if we open up the bracket, so we open up the brackets, gonna have x squared plus 2xh plus h squared minus 2x minus 2h. We have a minus 3x squared plus a 2x. All this is over h. Then limit as h tends to 0, we open up again, so 3x squared, 6xh, 3h squared, minus 2x minus 2h minus 3x squared plus a 2x. Okay, so remember with the first principles, the original will always cancel out. This is all over h. So this cancels this because the signs are opposite. This cancels that, the signs are opposite. And now our next step will be just to factorize out the h. Okay, so if h comes out, we have a 6x there. We have a 3h, we have a minus 2 over h. So this h cancels that. And then the next step will be just to replace h with a 0, meaning that we have 6x plus 3 times 0 minus 2, meaning that our derivative is just 6x minus 2. All right, then 6.2.1. 6.2.1. They're telling us that okay, we must simplify this if the limit of h tends to 3. Now, it doesn't make sense if the question says the limit of h tends to 3. It should be like the limit of x is tending to 3. That would be the reasonable kind of expression to use, not necessarily h. I don't know why they used h in this case. Okay, so let's for us to answer this, we just need to factorize out what is common. Okay, we need to factorize out what is common, meaning that we're gonna have a 2x For us to get 15, we need the 5 and the 3. Let me put let me put a 3 here. If I put a 5 here, that's gonna be 6x. This is gonna be 5x. Okay, minus over. I'll take out the negative here so that I have my x minus 3. We're saying limit should be x tends to 3. So this is gonna cancel that. When I introduce the negative sign, I'll have negative 2x plus a 5. Now, if x tends to 3, now I can replace x with a 3. But I have negative 2 times 3 plus 5. So negative 6 plus 5, I'm getting my answer as a negative 1. Okay. So this should be just x. All right, then 6.2.2. They want us to find the first derivative of g if g of x is this. So the tricky part is just for us to move the x to the top so that we have x to the 4 minus 4x to the negative 1. Then our first derivative is just going to be 4x cubed plus, that is 4x minus 2. So that's the answer to the question. Then 6.2.3, they also want us to find the derivative. If y is this, we open the bracket. So that's going to be 3x. That's going to be minus x squared plus 9 minus 3x. Does that make sense? Because say 3x minus x squared plus 9 minus 3x. Okay, that's your y. So this cancels that. We're left with negative x squared plus 9, meaning that the y dx is going to be negative 2x. 9 is a constant, so it has no derivative, okay? Or its derivative is a 0. And then 6.2.4, I'll put it this side. 6.2.4. We're being told that dx, okay, we must look for dx of 3 root x minus 4. And I'm dividing this by root of x. Okay, so what I'll do, split this up first. So it's 3 root x over root x minus 4 over root x. So that cancels. We have 3 minus, I'll say 4x to the negative a half, because we know that root x is the same as x to the exponent of a half. And then I need to find the x of this. So it's a constant, that's a 0. This multiplies with a negative 4, which becomes a plus 2. X, when we subtract a 1, negative 3 over 2, meaning that our final answer is 2x negative 3 over 2. That's our answer. Okay, so that is what I'm getting, unless if anybody has a different idea of how to, because negative a half minus 1. Yeah. Okay, then 6.3, they want us to get the equation of the tangent to this graph at this point. So step number 1, let me get the points, okay, where the tangent is meeting. Okay, we need the y coordinate. So I'll say f of negative 2. So it's negative 2 squared plus, it's gonna be a 4 plus a 3. Somebody will take offense in that, okay. So meaning we have a 4 plus a 4 plus a 3, which gives us what, 11. So we have a point negative 2 and 11. Then we need to find the first derivative of x and then substitute with a negative 2 to get the gradient at that point. So it's going to be 2x minus 2. And then the first derivative at negative 2, remember we said 2 multiplied by negative 2 minus 2, which gives us a negative 6. So our gradient is a negative 6. And this is the point of interest. So we can use y minus y1 is equal to m into x minus x1. So y minus 11 is equal to negative 6 into x minus minus 2. You open up and you make y the subject, so it's negative 6x minus 12 plus 11. So our desired equation is negative 6x minus 1. So that is the equation. Or you can use the y is equal to mx plus c, and then you look for the c. Whichever way you do it, the answer should just remain the same. All right, question number 7. Sketched below. Okay, we have a graph that was sketched below for us. Okay. This is the F point A, B, C. We have C, which is 6, 0. Those are the x-intercepts, and we have turning points. Then the first question, they want us to get the coordinates of E. So we know that E is a turning point. For us to get the turning point of any cubic function, we must look for the, what do you call it? The first derivative. Which color will I use? Let me use red, it's fine. So the first derivative, okay, is going to be 3x squared minus 10x minus 8 is equal to 0, because the gradient or turning point of 0. Then we need to factor this out, 3x and x, for us to get 10. Sorry, for us to get 8, we can use 4 and 2. Can have this as a negative and a plus. So x is a negative 2 over 3, or x is a 4. Okay, so the 3 over 2 negative is here. And then this should automatically be a 4. Then if this is a 4, we need the y coordinate of this 4. So let's substitute and say f of 4. So 4 cubed minus 5 times 4 squared minus 8 times 4 plus 12. So 64, that's 16 minus 80 minus 32 plus 12. Okay, so if I'm to substitute that into the calculator, let's see what we get. So 64 minus 80 minus 32 plus 12. I'm getting a negative 36. So our E is a 4 and negative 36. Okay, then write down the equation of the tangent, ME. Okay, to the graph of F. So this is a horizontal line that is parallel to the x-axis, meaning that our y should be equivalent to negative 36. It's more like an asymptote for the hyperbolas. All right, then they want us to get the length of TM if M is on the y-axis. So what is the y value here? Does that make sense? Nope. Y value is negative 36, yes. But then the x is a 0. Okay, x is a 0. This is a 4. They want the length, TM. Oh, this is EM. Where is TM? Oh, this is TM. So if this is a negative 36 for the y, what is the coordinate of this y-intercept from the equation? It's here. It's a 12. Ne? So meaning that we're going to get the 12 plus the 36. Okay, so I'll either say 12 plus 36 to give me 48 units, or I'll write it as 12 minus 36, which is 48. Or you can use your distance formula, whichever way you want to do it, okay? 7.2, we have a description of a function, and then they want us to sketch the function. All right. So P is a cubic function with the following conditions. So the shape of a cubic can be like that, or it can be in that sort of format, okay? So A is less than 0. So if A is less than 0, meaning that this is the correct shape to go with. then P of 0 is 0. What does that mean? When X is 0, Y is also 0, meaning that this graph is passing through the origin. And then the first derivative of 1 is 0. What does this tell us? That we have a turning point at 1. We also have a turning point at 3. Okay, so let's do this. We don't know the intercepts, né? We don't. Only thing we know is that there is a turning point at 1. There's also a turning point at 3. But we said this is the shape we're having. So if our turning point is having a y value somewhere here, this turning point is having a y value somewhere there. If I'm to sketch this, it would come up to something like that. I don't know, based on this. So they said use the information to draw a sketch showing all the intercepts. So this is an intercept. This is also an intercept. That is also an intercept that we know nothing about. Okay, but now, there's a problem. There is a problem because they told us it's a problem here. We said if it's a 1, then we have a 0. Does it make sense? Then if it's also 3, it's also 0. Yeah, why did we erase that? Because the gradient is 0 at this point. Okay, this does not mean that the coordinates are 1 and 0 or 3 and 0. No, that is wrong. Okay, so the other thing that we cannot substitute since we don't have the values of A, B, and so that is the sketch that we would have drawn there. Okay, had it been that the question told us that P of 3 is 0, then the graph was supposed to cut this point as well. Okay, so the way we treated the 1 is the same way we treated 3. Okay, so that is question number 7. Lastly, question number 8, optimization. The figure represents a large stained glass window frame, and then the upper part is a semicircle. Lower part is a rectangle with sides 2x and y. The perimeter of the window frame is 30 meters. Can we show that y is given as this? They want the perimeter. So we know that for us to get the perimeter of this entire thing, we can get the perimeter of the semicircle as well as add these 3 sides to the perimeter of the semicircle, and then we shall be good to go. All right. So we know that the circumference of a semicircle, is it called circumference? Yeah, it's given as 2 pi, the full circle, 2 pi radius. But now, since we're dealing with half of a circle, okay, it's going to be a half times 2 pi radius, which is the same as pi radius. But then our radius, if this diameter is 2x, meaning that the radius is going to be x. So our circumference we're talking about is pi x. So our perimeter is going to be pi x plus the y plus the 2x plus the y. They told us the perimeter is 30. So 30 is equal to pi x plus 2y plus 2x. They want us to make y the subject. Okay, so meaning that 2y is equivalent to 30 minus pi x minus 2x. So let's take it out of pi x. So meaning that y is going to be 30. Let's take out the negative x. We shall have a pi plus 2 or 2 plus pi. Then I'm going to divide this by 2. So that is what the question technically wanted. Then 8.2, calculate the value of x for which the area of the window frame would be maximum. We must leave the answer in pi. Now, they're switching the story now to area. So for us to get the area of the window frame, because this entire thing is a window frame. So let me call this A, and then I'll call this B. So for me to get the area of A, which is a semicircle, plus area of B, which is a rectangle, so that's going to be a half pi radius squared plus length times the width. So that's a half pi. Our radius was x, plus the length is 2x multiplied by y. This is area. We simplify this. We have, is there anything to simplify? We can just say half pi x squared plus 2y x. Okay, so for us to get maximum, calculate the value of x for which the area is. So you must find the derivative, the a by dx, which is going to be pi x plus 2y. It should give us a 0. Okay. And then from there, does it make sense though? Because we already have what y is. Do I need to substitute it at that level? I think I should. Okay, so I'll be left with pi x plus 2. Then our y was 30 minus x into 2 plus pi. All this is over 2 is equal to 0. So this is going to cancel that. Okay. If I try to open this up, I'll have a pi x plus a 30 minus 2x minus pi x is a 0. Pi x and pi x are canceling out, which means there is something that I might have omitted, because they're telling us we must leave our answer in terms of pi. So if that is the case, then I have to go back before I find the derivative. I just need to do the substitution. Okay, so we said this is a half. Okay, so a half pi x squared plus, remember this was 2x. Okay, this is 2x. We said our y was 30 minus, I'll open it up, 2x minus pi x. Everything is over 2. Let these 2 cancel that 2. Okay, so that I know I'm left with just a half pi x squared plus a 30x minus 2x squared minus pi x squared. Okay, then let me get the derivative, the a by dx. That's gonna be pi x. Okay, this is plus 30 minus, this is gonna be 4x minus 2 pi x is equivalent to 0. Okay, so when I subtract this and this, we're gonna have a negative pi x minus 4x should be equivalent to negative 30. Divide through by negative, meaning that your pi x plus 4x should give us a 30. Take out the x. You have a pi plus 4 giving me a 30, meaning that your x should be a 30 over pi plus 4. So that's what the question wanted. And that brings us to the end of the paper. So I would say out of 100, this paper was fair. It was more than fair. All right, guys. So I wish you the best in your preparation for paper one, and as we wait for the results of paper one. Let's meet when we meet. Bye-bye.